In a binary frequency shift keying FSK, in binary FSK, the given signal waveforms are U0 of t is equals to that signal, and U1 of t is equals to that signal over that duration 0 to capital T, where capital T is a bit duration interval and t is in seconds. Both U0 of t and U1 of t are 0 outside the interval 0 to capital T. With a matched filter correlator based receiver, what is the smallest positive value of capital T in microseconds required to have U0 of t and U1 of t uncorrelated? Okay, so we have a situation where you require two signals or two waveforms to have zero correlation. Now the condition for zero correlation is similar to that of orthogonality, that usually if you have two signals being uncorrelated, and they are also said to be orthogonal, and if two signals or two waveforms are orthogonal, then their correlation is zero. That means they are uncorrelated. And we've seen this condition before, that then the integral, the integral of the product of those two waveforms must be zero. And we're not going to perform that integral because we've done that before, but we simply evaluate the integral and we'll know it will lead us to two signals that have two frequencies, or two waveforms with two frequencies, where one frequency is f1 minus f2 and the other is f1 plus f2. In our case, f1 is 8000 Hertz and f2 is 48 Hertz. Now 8000 plus 48 would be f1 plus f2 is 8048, and f1 minus f2 will be 7952. These two frequencies are so close together, and we know we'll end up with an integral that resolves to something similar, something like this. Sine 2 pi times 8048t over 2 pi times 8048 plus sine 2 pi multiplied by that over that interval 0 to capital T is equals to 0. And we have, basically, when you solve that, you end up with this. Now, if we inspect this equation carefully, we will realize that the only way this sum can be 0 is that both of these numerators must be 0. And the only way that can happen is that both of these must be integer multiples of pi, like n pi, because we know sine n pi is always equal to 0. So sine 2 pi, rather 2 pi times 8048t and 2 pi times 7952t, both of these must be equal to n pi. And if we say, for example, the simplest case where n is 1, then 8048 pi capital T should be equal to pi. And notice we are ignoring the 2 pi because 2 is still an integer value, and that means we really can ignore it. It's not, we don't have to include it in our calculation. So 8048t is equals to pi. That means t is equals to 1 over 8048. That approximates to 125 microseconds. Now, in other cases, you could actually ignore these 8000 plus 48 because 8000 is much greater than 48. So this solves to something very close to 1 over 8000, which is approximately 125 microseconds.